Alright, so these are the notes for 5.5, which is real zeros of a polynomial function. And before we go into these notes, I need to make sure everybody's okay with synthetic division. So I'm just going to do kind of an example or two. Let's say we wanted to have a polynomial x to the third minus 5x squared plus 6x plus 1. And we wanted to divide it by x minus 2. Okay. Well, in order to do this division really quickly, we do what's called synthetic division. First off, take this part you're dividing by and set it equal to 0. Move the 2 over and you get x equals 2. And so what you're going to do is you're going to draw a little backwards L, which I usually call the box. Okay. And up in this box, you're going to put your number, which you just got, which is 2. Next to the box, you're going to write your coefficients from your polynomial here. So the coefficient on the x cubed is 1. The coefficient on the x squared is -5. The coefficient on the x is 6. And our constant is 1. And then you're going to draw a line underneath, and you're going to drop down the first term. And so that's all of your kind of preliminary setup for synthetic division. Once you get to that point, then you can actually do the process of synthetic division. And that process boils down to two basic steps. You multiply diagonally, and you add vertically. So I'm going to multiply diagonally. I'm going to take 2, and I'm going to multiply it diagonally by this 1. What is 2 times 1 is 2. And I put my answer right there. And then I add vertically. I add up and down. So -5 plus 2 gives me -3. Then I repeat the process. Multiply diagonally. What is 2 times -3? It's -6. Add up and down. 6 plus -6 is 0. And we multiply diagonally again. 2 times 0 is 0. 1 plus 0 is 1. Okay. Now this right here tells you something about your answer. This first part right here is always the remainder. This number here at the very tail end, it's always the remainder. This one is always your constant. And then after the constant, you're going to count up your powers of x. So this is going to be x to the first power. This one is going to be x to the second power. And so if you were to write your answer that you got from doing this division, you would have 1 times x squared, which is x squared. You'd have -3 times x, which is -3x. You would have no constant, so you could write plus 0, but you don't have to. And then you have this remainder. How you deal with the remainder is you take the number for it, 1, and you put it over the thing you divided by. We divided by x minus 2, so we're going to put it over x minus 2. And that would be the result of our synthetic division. So when we divide this polynomial by this polynomial, this is the answer that we get. Okay? Let's do another one. Let's say we had x to the fourth plus 2x squared minus 3x plus 5, and we divide it by x plus 1. Well, again, the very first thing you're going to do is you're going to take this right here and set it equal to 0, and then you'll solve, and you get x equals -1. Put that in your little box. Next to this box, we're going to put our coefficients. So our x to the fourth, our coefficient is 1. And then I don't have an x to the third. So since I don't have an x to the third, I'm going to put a 0 in for it. Because there are no x to the thirds here, so I'm saying I have 0 x to the thirds. Then I go to x to the second power. I have 2 of those. I go to x's, I got -3. And then I go to constants, I have 5. I draw my line, I bring down that first number. I bring down the 1.
And then you're ready to do the process of
Synthetic division. Multiply diagonally. -1 times 1 is -1. Add vertically. 0 plus -1 is -1. Multiply diagonally. -1 times -1 is +1. Add up and down. 2 plus 1, 3. Multiply diagonally. -1 times 3 is -3. Add up and down. -3 plus -3 is -6. Multiply diagonally. -1 times -6 is +6. 5 plus 6 is 11. So this number here at the end, again, is your remainder. This next one is your constant. And then after your constant, you go through powers of x. So this is x to the first power. This is x to the second power. This is x to the third power. So we have 1x to the third, so we have x to the third. We have -1x squared, so that's -x squared. We have 3x. We have a -6. And then we have a remainder, which is 11. And we put that over our divisor, which was x plus 1. And so that's what we would get if we did the division.
Okay.
If you need to, go back and rewatch those. Make sure you understand the process. But for 5.5 and 5.6, you're going to be doing a lot of synthetic division because we're going to be talking about how to find out information about polynomials. And one of the easiest ways to do that is with synthetic division. Alright, so let's actually get into the 5.5 notes. 5.5 and 5.6 have a bunch of theorems in them, so we're just going to kind of go through each one. Our first one is the remainder theorem. And the remainder theorem says that the remainder you get when you do synthetic division is the same thing as the function's value. Meaning, if I want to find f of c, then I can find it by doing the division by x minus c. Okay? So do the division using that number c, and you'll get your same thing as if you'd plugged the number into the function. So let's look at an example of that. Example 1 here, we are given that f of x equals x to the third minus 4x squared plus 5x plus 3. And they ask us to use the remainder theorem to find f of 2. So I want to know, what does f of 2 equal? Well, to find f of 2, we are going to do synthetic division using that number 2. So I'll put 2 in here. Next to it, I'll put the coefficients of my polynomial, 1, -4, 5, and 3. Drop down the 1, and then do synthetic division. 2 times 1 is 2. -4 plus 2 is -2. 2 times -2 is -4. 5 plus -4 is 1. 2 times 1 is 2. 5 plus 2 is 3. This right here is my remainder. So according to the remainder theorem, f of 2 is the same thing as my remainder, so f of 2 is equal to 5. I do not have to write out the whole polynomial, because the remainder theorem is just talking about the remainder. It's saying you can find f of c by looking at the remainder from when you divided by c. So, pretty straightforward, pretty easy. The next thing is the factor theorem. The factor theorem is kind of like a corollary to the remainder theorem. It basically just says that if your remainder is 0, then that means f of c is 0, which means that c is an x-intercept or a 0 or a solution of the function. So I'll say it again. If your remainder is 0, then that tells you that that is a solution to the function, and that x minus that number is a factor of the function. So let's kind of look at that in practice. Example 2 asks us to solve the equation 2x cubed minus 3x squared minus 11x plus 6 equals 0, given that 3 is a 0 of the function f of x equals 2x cubed minus 3x squared minus 11x plus 6. So they gave me that 3 is a 0. So I already know one of my answers is 3. But I have to find all of my answers. And just so you understand, whatever is the highest power in your polynomial, that's how many solutions you have to have. So I need to have 3 solutions, and I only have 1 right now. Well, the nice thing is, since they gave me one of them, I should be able to do synthetic division to simplify my polynomial. So I'm going to put that number they gave me, 3, here in my little box. And next to it, I'm going to put my coefficients. So 2x cubed, negative 3x squared, negative 11x, and 6. I'm going to drop down that first number, bring that 2 down, and then I'm ready to do the process of synthetic division. 3 times 2 is 6. Negative 3 plus 6 is 3. 3 times 3 is 9. Negative 11 plus 9 is negative 2. 3 times negative 2 is negative 6. 6 plus negative 6 is 0. And that kind of makes sense because, again, they already told us this is a 0. So that makes sense. Now, what's helpful about this is the remainder. This is the constant. This is the x. This is the x squared. So by doing this division, I've changed this function. And so now it's 2x squared plus 3x minus 2.
And the remainder is 0, so I don't really need to write that remainder down.
Well, now the function is just a quadratic.
And we know how to solve quadratics. You can complete the square,
Or you can use the quadratic formula, or you can factor if it's possible to factor. And in this case, this one is possible to factor. To make 2x squared, I would need to have 2x times x. To make a 2, I would need 1 times 2. I have to be careful. I have to decide, does the 1 go here or does the 1 go here? And to determine that, I look at the 3 in the middle. If I want it to be a 3, the 1's going to have to go here and the 2's going to have to go here. So that way I have 2 times 2, which gives me 4. And then I have a 1 in the middle, which can make it go down to 3. Now I need to make sure my signs are correct. So if I want it to be a positive 3, I need this to be a plus and this to be a minus. So that way I have 2x times positive 2, and I get positive 4x. And then I have negative 1 times x, which gives me a negative x. So it's going to make negative 3x. Take those factors and set them equal to 0. And then solve. Move your 1 over. 2x equals 1. Divide both sides by 2. X equals 1/2. So there's another answer. And on this one, subtract the 2. You get x equals negative 2. So there we go. And there are all of the answers to this. Are we okay there? If not, please just go back and watch that again. Hopefully it'll make sense. Alright. Now, in the previous example, they gave us one of the zeros. They told us, hey, 3 is an answer. But what if they don't give it to you? Well, if they don't give it to you, it is possible to make a list of all of the possible rational zeros. Now, rational zeros means things that are whole numbers or fractions. Okay? So this does not include things like square roots. It doesn't include things like imaginary numbers. Okay? This is only going to give us whole numbers and fractions. but it's going to give us a list of possibilities. And so it'll kind of help us narrow our search for answers down a little bit. Now, how do we make this list? Well, we do what is called P divided by Q. P on top is a list of all of the factors of your constant term. Q on the bottom is all of the factors of the leading coefficient. And then all you got to do is just divide those two, and that will create a list of all of the possible solutions, all of the possible answers. So let's make a couple lists here. So example 3 asks us to list all of the possible rational zeros for f of x equals negative x to the fourth plus 3x squared plus 4. So to make this list, I do P divided by Q. P is the list of all of my factors for the constant term. My constant term is 4. So what numbers can I multiply to get 4? Well, I can do 1 times 4, or I could do 2 times 2, or I could do negative 1 times negative 4, or I could do negative 2 times negative 2. So you might notice that I had a possibility of a positive 1 or a negative 1, and a positive 4 or a negative 4, and a positive 2 or a negative 2. So how we express that is we just say plus or minus 1, plus or minus 2, plus or minus 4. And those count for all my possibilities. On the bottom, I need my factors of my leading coefficient. In this function, my leading coefficient is a negative 1. How can you make negative 1? Well, positive 1 times negative 1. So this is plus or minus 1. Right. The next step is to actually do our division. Now, when you take a plus or minus and you divide it by a plus or minus, you're still going to get a plus or minus. So don't worry about that. Just focus on dividing the numbers. What's 1 divided by 1? 1. What's 2 divided by 1? 2. And then what is 4 divided by 1? 4. And they all still have the plus or minus. That doesn't really change. So there's my list of possible solutions, possible zeros. There's actually 6 possibilities. 1, 2, 4, negative 1, negative 2, negative 4. Okay? Now this one was pretty easy because the leading coefficient was a relatively small, simple number. But what if it gets a little more complicated, like here in example 4? Here in example 4, it asks us to list the possible rational zeros for f of x equals 15x cubed plus 14x squared minus 3x minus 2. And this is going to be a little bit more complicated. So we have P over Q equals, P is the factors for our constant. Our constant is negative 2. And the factors that can make negative 2 are plus or minus 1 and plus or minus 2. It's the only way you can make negative 2. On the bottom, we need the factors of the leading coefficient. Well, the leading coefficient is 15. What factors make 15? Well, 1 and 15, or 3 and 5. So I could have plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. So I have a lot of things down here. So it's going to make my list quite a bit longer. So when you do this division, you start by taking the top numbers and dividing them by this first number. Then you take the top numbers and divide them by the second number. And you take the top ones, divide it by the third, and so on and so forth. Okay. So 1 divided by 1 is 1. 2 divided by 1 is 2. 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. 1 divided by 5 is 1/5. 2 divided by 5 is 2/5. 1 divided by 15 is 1/15. And then on our last one, 2 divided by 15 is 2/15. And so there is my complete list. how many terms do we actually have? 1, 2, 3, 4, 5, 6, 7, 8, 2, 16. So now on this one we have 16 possibilities, which is quite a bit more. Now it's still better than having an infinite number of possibilities. You've narrowed it down quite a bit to only 16. That's still quite a few possibilities you're going to have to check if you had to do that problem. Okay. So that's how you make lists. It's pretty simple. And again, that helps you narrow your search for the answer down. So once you have this list, you can take any number on the list and you can do synthetic division with it. If it comes up with a remainder of 0, you know it's a solution. You know it's a 0 of the function. And so that's what we're actually going to be doing in our next example. So example 5 here asks us to find all of the zeros for f of x equals x to the third plus 2x squared minus 5x plus 6. So we're going to start by making our list of p over q. Our constant is 6, so our factors for it are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. On the bottom, our leading coefficient is a 1, so our factors are just plus or minus 1. When you divide each of these by 1, you just get plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. We have 8 possible answers. So let's try to find our answer. We'll start with trying 1, because that's our very first one we have, positive 1. So I'm putting 1 in here in my box. Next to it, I'm going to write my coefficients of my polynomial. So 1, 2, negative 5, and negative 6. Drop down that first number, so drop down the 1, and then do synthetic division. 1 times 1 is 1, 2 plus 1 is 3. 1 times 3 is 3. Negative 5 plus 3 is negative 2. 1 times negative 2 is negative 2. Negative 6 plus negative 2 is negative 8. This is not a 0, so that tells us that 1 is not a solution. 1 is not an answer. So, go on to the next number in your list. The next number in our list is negative 1. Again, write down your coefficients from your polynomial. 1, 2, negative 5, negative 6. Drop down the 1. Negative 1 times 1 is negative 1. 2 plus negative 1 is 1. Negative 1 times 1 is negative 1. Negative 5 plus negative 1 is negative 6. Negative 1 times negative 6 is positive 6. Negative 6 plus 6 is 0. Woo, yeah, we get a 0. Since we got a 0, that tells us that's one of our answers. So one of our answers is x equals negative 1. But the other nice thing is that now that we know that's a 0, we have a reduced polynomial because this is our constant. This is our x. This is our x squared. So we have a reduced polynomial that looks like this. X squared plus x minus 6. Now that is something that we can solve. We can solve it with either the quadratic formula, completing the square, or even factoring, because this one does factor. If you factor it, x squared needs to be x times x. To make 6, you need 2 times 3. And for it to be a plus in the middle, the 3 has to be a plus, the 2 has to be a minus. If you set those factors equal to 0 and solve, you get x equals 2 as another solution, and you get x equals negative 3. So there are our solutions to this equation. The idea is you make your list, you do synthetic division until you find an answer, And then once you have an answer, that gives you a reduced equation, and then you solve that equation. It's not too bad. Alright, so let's keep going. Example 6 says find all the zeros for f of x equals x to the third plus 7x squared plus 11x minus 3. So I'll start with my list, P over Q. My constant is 3, so I'm going to have plus or minus 1, plus or minus 3. My leading coefficient is 1, so I have plus or minus 1. So when I do the division, I get plus or minus 1 and plus or minus 3. So I have 4 possibilities. Let's start by checking 1. So I have 1 in here. I'm going to write down my coefficients, 1, 7, 11, and negative 3. Drop down to 1. 1 times 1 is 1. 7 plus 1 is 8. 1 times 8 is 8. 11 plus 8 is 19. 1 times 19 is 19. Negative 3 plus 19 is 16. That's not a 0. So that tells us that this is not one of our answers. So we go on to the next one. Let's try negative 1. So we have 1, 7, 11, negative 3. Drop down to 1. Negative 1 times 1 is negative 1. 7 plus negative 1 is 6. Negative 1 times 6 is negative 6. 11 plus negative 6 is 5. Negative 1 times 5 is negative 5. Negative 3 plus negative 5 is negative 8. That is also not a 0. So keep going. Let's go on to 3. 1, 7, 11, negative 3. Drop down to 1. 3 times 1 is 3. 7 plus 3 is 10. 3 times 10 is 30. 11 plus 30 is 41. 3 times 41, that's going to be 123. Negative 3 plus 123 is 120. So that's not a 0 either. So we're down to one possibility, negative 3, and we're going to hope and pray that that one works so that we can actually have an answer. Drop down to 1. Negative 3 times 1 is negative 3. 7 plus negative 3 is 4. Negative 3 times 4 is negative 12. 11 plus negative 12 is negative 1. Negative 3 times negative 1 is positive 3. Negative 3 plus 3 is 0. Yay, it actually was a 0. So we know one of our answers is x equals negative 3. And then again, we have a constant. We have an x. We have an x squared. So we now have this equation, x squared plus 4x minus 1. Now, does that factor? No. So in order to solve this, I'm going to have to use the quadratic formula. So I'm going to have to do x equals negative 4 plus or minus the square root of 4 squared minus 2 times 1 times negative 1 all over 2 times 1. And I wrote minus 2, that's supposed to be minus 4ac, not minus 2ac. Silly me. Okay. And then you'd want to clean this up. So we have negative 4 plus or minus. I'd like to know what's inside this square root, so I'm going to go to my calculator. So I've got 4 squared minus 4 times 1 times negative 1. So that gives me 20. And then on the bottom, 2 times 1 is 2. Can I simplify square root of 20? 20 is not a perfect square, but we could do a little factor tree. 20 is 2 times 10, and 10 is 2 times 5. So there are a pair of 5s right here, so a pair of 2s right there. So I could pull a 2 out and leave 5 behind. So I'd have negative 4 plus or minus 2 square root of 5 over 2. And then we can clean that up a little bit more. We can factor a 2 out of the top. When I pull a 2 out of this negative 4, it leaves a negative 2 behind, plus or minus. When I take a 2 out of this 2 square root of 5, I just leave behind the square root of 5 over 2. And then that 2 on top and the 2 on bottom can now cancel. And so this is what we're left with. So we have 2 more answers. We have negative 2 plus the square root of 5, and we have negative 2 minus the square root of 5. So there's my 3 answers for this problem. Now you might say, well, Mr. Murphy, why are these 2 answers not on my list right here? Well, remember your list is just a list of rational zeros, so it's only whole numbers and fractions. It's not going to include things like square roots. So those you kind of have to find with the quadratic formula. Okay? So that is example 6. Let's move on to example 7. Example 7 asks us to solve the equation x to the 4th minus 6x squared minus 8x plus 24 equals 0. And it tells us to note that 2 is a 0 of the function with a multiplicity of 2. This phrase multiplicity of 2 means that x minus 2 happens as a factor twice. Okay? It happens 2 times. If you factored this equation fully, this would be in your equation twice.
X minus 2, x minus 2.
Now, in terms of synthetic division, what it means is that you can actually use 2 times in your synthetic division. Okay? That's what the multiplicity means. It means you can move it, use it twice. So let's do that. I'm going to put 2 here. I'm going to write down my coefficients. I have 1x to the 4th. I have 0x to the 3rds, negative 6x squared, negative 8x, and positive 24. Drop down to 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 6 plus 4 is negative 2. 2 times negative 2 is negative 4. Negative 8 plus negative 4 is negative 12. 2 times negative 12 is negative 24. 24 plus negative 24 is 0, which we should expect since they told us it was a 0. But now that's reduced this equation. This is my constant. This is my x. This is my x squared. This is my x cubed. So what I have is x cubed plus 2x squared minus 2x minus 12. That's what it's reduced to. But we know that this 2 has a multiplicity of 2, so that means I can divide with it again. So I'm going to divide by 2 again, but this time I'm going to use these coefficients. So I'm going to have 1, 2, negative 2, negative 12. Drop down the 1. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. Negative 2 plus 8 is 6. 2 times 6 is 12. Negative 12 plus 12 is 0, which again we should expect because they did tell us it's a 0. And now this is my constant, and this is my x, and this is my x squared. So I have x squared plus 4x plus 6. Up here, I'm going to write down my answers. I know x equals 2 is an answer. You could write it twice if you want to, because it does happen 2 times, but you don't need to. Once you write it once, you're counting for both of these times. Okay. All right, now that we have a quadratic, we can solve. Now, this quadratic, I can't factor it, unfortunately, so I'm going to have to use the quadratic formula. So I'm going to have to say x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 6, and put that all over 2 times 1. So that gives me negative 4 plus or minus a square root, and then I go to my calculator to figure out what's inside that square root. 4 squared minus 4 times 1 times 6. There is a negative 8 inside that square root. On the bottom, 2 times 1 is 2. Now remember that when you have a negative inside the square root, you pull it out as an I, so that's I square root of 8. There. Now can we simplify square root of 8? Well, 8 is not a perfect square, but we could do a little factor tree for 8. 8 is 2 times 4. 4 is 2 times 2. So there is a pair of 2's there. So I could pull a 2 out. So this becomes 2i. And then left over inside is this other 2. 2. And then we could simplify that a little bit more. We can factor a 2 out of the top. When I pull the 2 out of this negative 4, it leaves behind a negative 2, plus or minus. When I pull a 2 out of this 2i square root of 2, it just leaves behind I square root of 2. And then the 2 on top and the 2 on bottom can cancel, and so I'm just left with this. So my other answers are negative 2 plus I square root of 2, and negative 2 minus I square root of 2. So my other two answers ended up being imaginary, and that's okay. It's fine. So you might be saying, well, Mr. Murphy, didn't you say that the highest power tells you how many answers you should have? Yeah, it does. In this case, the highest power is 4, so I should have 4 answers. Now, if you just count what I have boxed there, you only see 3 answers. But remember, this x equals 2 has a multiplicity of 2, so it actually counts twice. So there are 2 answers here, and then 3, 4. So there end up being 4 answers total. So that's that one. The next thing we're going to talk about is Descartes' rule of signs. This is not a method for really finding your answers, but it is a method for telling how many possible positive answers you have and how many possible negative answers you have. So Descartes was a mathematician, a philosopher, a politician, a historian, just a bunch of different things. And he contributed quite a bit to mathematics. And one of the things he did was study polynomials, and so he came up with this rule of signs and proved that it had to be true. The rule has 2 parts. One part for if you're looking for positive zeros, positive answers, and one part if you're looking for negative zeros, or negative answers. So, for the first part, to find the number of positive zeros, you're going to look at the sign changes in f of x. You're going to look at how many times f of x changes signs. Now, Descartes said once you look at this sign change, your answer is going to be one of 3 things. It's either going to be that number of sign changes, or it's going to be less than that number by an even integer, meaning counting down by 2, so either 2 less, or 4 less, or 6 less, or 8 less, or 10 less, etc., etc. Or if there's only one sign change, then you only have one positive zero, only one positive answer. In terms of negative answers, negative zeros, he said you need to look at the sign changes in f of negative x. And your answer is either going to be the same as the number of sign changes of f of negative x, or it's going to be less than that by an even integer, so less by 2, or less by 4, or less by 6, etc., etc. Or if you only have one change in sign for f of negative x, then you only have one negative 0. And so here's a little table kind of showing you how to do the positive checks a little bit. So here's a function, polynomial. It has 3 sign changes. It goes positive to negative right here. It goes negative to positive right here. And then it goes positive to negative right here. So according to Descartes, because there are 3 sign changes, we either have 3 positive zeros, or we go down by an even number, so go down by 2, we have 1 positive 0. So we either have 3 or we have 1. So this next one, we have another polynomial. This one only has 2 sign changes. Right here, it goes from a positive to a negative. And then right here, it goes from a negative to a positive. So there's only 2 sign changes. So according to Descartes, that means there's either 2 zeros, or if we go down by a even number, we can go down by 2, we get 0. So there's either 2 positive answers or there are no positive answers, according to Descartes. If you look at the last one, here's another polynomial. This one only has 1 sign change. It goes negative to positive right here. And so according to Descartes, if there's only 1 sign change, that tells you there is exactly 1 positive answer. Exactly 1 positive 0. So that's how the rule of signs works. You just count the sign changes, and that helps you figure out how many positive and negative answers you have. Alright, so example 8 asks us to determine the possible number of positive and negative real zeros. So we start by looking at sign changes here. It goes positive, 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 positive. So it never changes signs. Since it never changes signs, that tells us there are no positive real zeros. Okay? And that's just because there were no sign changes. Now let's check negatives. To check negatives, I need to know f of negative x. So I have negative x getting cubed plus 2 times negative x getting squared plus 5 times negative x plus 4. Right. When I take a negative x and I cube it, I get a negative x cubed. When I take a negative x and I square it, I get a positive x squared times a positive 2, so I get plus 2x squared. Here I have a positive 5 times a negative x, so I get a negative 5x. And then here at the end I have a plus 4. So looking at this, how many sign changes do I have? Well, I go negative to positive, so that's 1. Positive to negative, that's 2. Negative to positive, that's 3. So according to Descartes, I'd either have 3, or if I go down by an even number, I can go down by 2. What is 3 minus 2? That's 1. So I either have 3 or 1 positive, not positive, this is negative, sorry. So we're looking at f of negative x. So we either have 3 or 1 negative real zeros. Okay? And so that's Descartes' rule of signs. It's pretty straightforward. Alright, we're going to skip the bounds on zero theorem because it's not really super useful. And we'll go to our very last thing, which is the intermediate value theorem. Right. The intermediate value theorem says if you have a function and f of a and f of b have opposite signs, then there had to be a 0 somewhere between f of a and f of b. And this kind of makes sense, okay? If you think about a graph, if you have a point here at A, down here, and then when you get over here to B, you have a point up here. In order to go from here to here, you had to go across the x-axis. So you had to have crossed 0. And so you had to have an answer there. It also works in the reverse. You know, if A is up here and then B is down here, well, if you go from here to here, you're going to have to cross that x-axis, and so you're going to have a solution. It's kind of a common sense theorem. So let's actually look at an example of this. It says, show that f of x equals x to the 5th minus x to the 3rd minus 1 has a 0 between f of 1, or between 1 and 2. So to do this, I need to figure out what is f of 1 and what is f of 2. Well, to do f of 1, I plug 1 in for all the x's. So I have 1 to the 5th minus 1 to the 3rd minus 1. 1 to the 5th is 1. 1 to the 3rd is 1. So this is 1 minus 1, which is 0, minus 1, which is negative 1. Alright, f of 2, we plug 2 in for all the x's. So we have 2 to the 5th minus 2 to the 3rd minus 1. 2 to the 5th is 32. 2 to the 3rd is 8. So 32 minus 8 gives us 24, minus 1 gives us 23. So we went from having a negative y value to having a positive y value. So it means we have a picture that looks kind of like this. So we can tell that a 0 must occur on that interval 1 to 2. And you can actually kind of verify that if you go in and graph this function. Say x to the 5th minus x to the 3rd minus 1. If we actually graph it, you can see it crosses here in between 1 and 2. And we can even zoom in a little bit to make it a little easier for us to see. So see here, this little tick mark is 1, this little tick mark is 2. So in between those two, it is crossing the axis here. And so here's our value of negative 1 down here, and the value of 23 is way off the screen somewhere. But you can see in between those two, it had to cross. And we proved it by looking at these signs. Because it went negative to positive, we know a 0 had to occur there. Okay? Alright, so that is it for 5.5. As always, if you have any questions, feel free to shoot me an email.